Hey there, and welcome. Today, we're going to tackle a math symbol that, let's be honest, can look pretty intimidating, the radical. But what if I told you it's not nearly as scary as it looks? In just the next few minutes, we are going to completely demystify this thing, and you're going to walk away feeling confident enough to handle them with ease. So let's jump right in. Have you ever looked at a math problem and just felt like you're trying to read a secret code? You know, just a jumble of symbols and numbers that seems totally impenetrable? If that sounds familiar, well, you are in exactly the right place. We're about to hand you the key to unlock one of its biggest secrets. Okay, so check this out. At first glance, this is a mess, right? It's a complicated-looking problem with no obvious place to even start. This right here is the secret code we're going to crack together. And I promise you, by the time we're done here, a problem like this is going to look totally straightforward. All right, so first things first, let's meet our main character, the radical symbol. I want you to think of it less as some scary math operator and more like a machine, a simple machine with one single job, to find the root of a number. So what does that actually mean? Well, you know how 5 squared, or 5 to the power of 2, is 25? The radical, or the square root, it just does the complete opposite. The square root of 25 is 5. See? It just undoes the exponent. It's as simple as that. Now, to really get comfortable with this thing, we gotta know its parts, right? So, like any good mechanic, let's pop the hood and see what makes this little machine tick. You'll see there are really only a couple of key pieces to understand. So we're gonna use this expression right here as our guinea pig. Every little part you see has a specific name and a specific job. We're gonna break it all down, piece by piece, starting from the inside and working our way out. Okay, first up, that number inside the symbol, that's called the radicand. In our example, it's the number 8. This is like the raw material that our little machine is going to work on. It's the number we need to find the root of. And what about that little number tucked away in the corner? That's the index. It tells the machine which root it's supposed to find. So here, the index is 3, which means we're looking for the cube root. What number times itself 3 times gives you 8? Right, it's 2. But here's the super important part. You ready? If you don't see an index, it's not missing. It's just an invisible 2, which means you're finding the good old square root. Okay, now that we know the lingo, let's get to the most important skill you'll need, simplifying. This is the absolute key to unlocking the tougher problems. This is all about taking something that looks kind of messy and just cleaning it up, making it neat and useful. All right, let's take the square root of 48 and simplify it together. First step, we need to find the biggest perfect square that divides into 48. You know, a number like 4, 9, 16, whose square root is a nice whole number. For 48, the biggest one is 16. So we rewrite our problem as the square root of 16 times 3. And this is where the magic happens. We can split that into 2 separate radicals. We get the square root of 16 times the square root of 3. We know the square root of 16 is just 4, so our final simplified answer is 4 times the square root of 3. See? We've cleaned it right up. Okay, so where do we go from here? What happens when you have to add or subtract these things? It might sound like a whole new set of rules, but what if I told you that you already know how to do this? If you can combine like terms in algebra, you've got this. Just look at this. The logic is exactly the same. On the left, you've got 7x plus 2x. You can combine them because they have the same variable, x. Well, on the right, it's the exact same idea. You can combine these because they share the same radicand, the square root of 5. That radical, that square root of 5, it's basically just acting like the x. So here it is, the golden rule for adding and subtracting radicals. The radicands have to match. They have to be identical. If they are, you just add or subtract the numbers out front and you leave the radicand completely alone. That's the rule. So you're probably thinking, all right, I get addition. What's the catch with multiplication and division? Well, I've got some great news for you. The rules actually get even easier. When you're multiplying, it's so simple. You just multiply the numbers on the outside, and then you multiply the numbers on the inside. That's it. You don't have to worry about the radicands matching. As you can see here, 2 times 5 is 10, and 3 times 7 is 21. And guess what? For division, it's the same exact logic. Divide the outsides, divide the insides. All right, and here it all is in one handy little cheat sheet. Just notice that huge difference.
For addition and subtraction, you've got that one big requirement. The radicands must be the same. But for multiplication and division, it's a free-for-all. You can just go for it.
Okay, it's time. Remember that problem from the very beginning? The one that looked so complicated? Well, guess what? Because right now, you have every single tool you need to solve it. Let's put it all together and crack this code.
So here we go. 4 times the square root of 12 plus the square root of 75. You can see right away the radicands. 12 and 75 are different, so we can't add them yet. Our first job is to simplify. We'll take that first term. The square root of 12 simplifies to 2 root 3. Multiply that by the 4 that's already out front, and our first term is now 8 root 3. Now for the second one. The square root of 75 simplifies down to 5 root 3. And, would you look at that? Our messy problem is now 8 root 3 plus 5 root 3. The radicands match, so now we just add the numbers out front. 8 plus 5 is 13. Our final answer is 13 root 3. And just like that, the code is cracked.
And there you have it. You took a problem that looked super complex, you applied a few simple, logical rules, and you found a clean, simple solution. You didn't just stumble on an answer, you learned the language.
So that thing that looked like a secret code just a few minutes ago, yeah, that's now just another tool in your math toolbox. So I want to know from you, what other mathematical monster should we take on and demystify next?